I'm going to show you how to work through the quiz review for the similarity quiz. So the first set of problems are all about proportions and solving for an unknown value. We can see here that we have 5 is equal to 60 over x equals y over 25. So we actually have 3 proportions, but in solving these, we want to isolate 2 at a time. So I could say that 5 equals 60 over x, and I can solve this. So I'll put 5 over 1, and I want x out of the denominator, so I'm going to multiply both sides by x, leaving me with 5x is equal to 60. I'll divide both sides of the equation by 5, and we get x equals 12. Looking back to this original proportion, I can now solve for y. I could use 5 again, so I could say 5 equals y over 25, and I can use this to solve. Or if I chose, I could use my new value of x. So I can say 60 over 12 equals y over 25. So I can do it either way, and I'm just going to choose this one for our purposes. So we'll clear that. And we'll move this right here. Okay, so now if I want to solve this, I probably want to get rid of my denominator, so I'm going to multiply by 25 on both sides. Cancel this. 60 times 25, we can put that into a calculator. We get 1,500 divided by 12 is equal to y. So I've isolated my variable of y, and now I want to see, does 1,500 divide by 12 evenly? It does. Y must be equal to 25. And we said a minute ago that x was equal to 12. And we should box our answers, especially on quizzes and tests. It makes it much easier for me to find your answer and get you as much credit as you possibly can. Okay, so that's example 1. Clear this over. In number 2, same thing. Now we have 3 proportions. X over 5 equals 20 over x equals y. So it's a little bit trickier here because now every single proportion has a variable in it. We have to choose these 2 because both of these proportions have x, which will allow us to solve for x. If we choose an x and a y, we're never going to be able to solve for one of the variables because we'll always have the other one there as well. So if we look at x over 5 equals 20 over x, we want to get all our x's on one side, and we definitely want to get x out of the denominator. So I'm going to start by multiplying both sides by x, which cancels. We get x times x is x squared over 5 equals 20. Okay. And now we can multiply both sides by 5. And we get x squared is equal to 100. And then we take the square root of both sides of the equation to solve for x. So x is equal to 10. And now you might say, oh, well, couldn't it be positive or negative 10? And in some applications, yes, but we're talking about side lengths basically with the ratios and proportions, and we're probably not interested in thinking about a negative side length. So we're just going to take the value of x equals 10 here, and that's what we'll use. Okay. Now we can use that to figure out what is y. So we can take x equal 10 and we can substitute it back into either proportion. I'm going to pick 20 over x equals y. We substitute this 10 back in for x, and 20 over 10 equals y, 2 equals y. And if you would put the x in for 10 over 5, you would also get the same thing. I'm going to box up my answers here like a kind of weird Lego piece, and we are good to go. So again, there were a lot of variables, but we just wanted to isolate in on the 2x variables, the 2 proportions with x in them, and that allows us to solve. And just like in the last one, we usually want to get the variable out of the denominator. Okay. In example C, so now we have 3 proportions. We have x's, we have y's, and we have 2/7. So now when I decide which ones I want to do, I could either choose this proportion because that'll let me solve for x. My only variables are x's. Or I could choose to use these two proportions because those are all y's. Do either of them look easier? Maybe, maybe not. I'm just going to choose to do the x's. So we can say x minus 1 over x equals 2 over 7. Okay, we have an x in the denominator. We want to solve for x. We want it out of the denominator. So we're going to multiply both sides of the equation by x. Canceling. We get x minus 1 equals 2x over 7. We would like to get that 7 out of the denominator, so we can multiply both sides by 7. Remembering we are multiplying everything, so we have to distribute this 7 to the x and the minus 1. So we get 7x minus 7 equals 2x. Here we want all our x's on one side of the equation. I'm going to choose to subtract 7x from both sides. So I get negative 7 equals negative 5x. And now to isolate x, I simply divide by negative 5. Negative 7 divided by 5 gives me x is equal to, 7/5. Okay. And if that seems like an answer that we're not as confident in, it's not an integer, and we think, oh, maybe we want integers, we can actually plug that back in and check to make sure we have the right answer. So if I erase this, we want to see, does x equal 7/5 actually work here? So I can say 7/5 minus 1 over 7/5. Does that actually equal 2 over 7? I want to check this. We could do all this math with the fractions, but that would be a little annoying to start. What I'm going to use is the fact that if we are dividing by a fraction, that is equivalent to multiplying the reciprocal. So I can rewrite this as 7 over 5 minus 1 times 5 over 7. So I'm going to multiply by the reciprocal of the denominator rather than dividing. Okay. So now if I distribute everything in, I can distribute to this term and this term. Well, 7/5 times 5 over 7, the 7's cancel, the 5's cancel, that is equal to 1. So we get 1 minus, and then negative 1 times 5/7 is just negative 5/7. So we get 1 minus 5/7. And we want to check, does that equal to 2/7? Well, 1 is equivalent to 7/7. We subtract 5/7, and it is 2/7. So we have checked our x solution is correct here. Okay, so now we're going to solve for y. And remember, since this is a video, you can always pause and go back and review anything if I went a little too quickly for any part. So we'd use the same idea for y. 2 over 7 equals y over y plus 1. And I don't want y in the denominator. I really don't want a denominator at all if I can help it. So I'm going to multiply by this whole denominator on both sides, y plus 1. Okay? Because if I multiply and divide by y plus 1 on the right side, it equivalently cancels and we are just left with y. On the left side, I need to make sure to distribute. So I get 2/7 y, or 2y over 7, plus 2/7 times 1 is 2 over 7. And there's multiple ways you could go about solving this, but I see that we have a common denominator on the left, so I'm just going to combine my two fractions to be 2y plus 2 over 7, because this allows me to get rid of the denominator now. If I multiply both sides by 7, and I'm left with 2y plus 2 equals 7y. Okay. And I am going to erase to give us some more space here. Okay, we'll bring that up. Now I can get all my y's on one side of the equation. subtract 2y, and I get 2 equals 5y. Dividing my 5 to isolate y, we get y equals 2 over 5. Awesome. And we could check that answer, but I'm not going to because I know that's the right answer, but I encourage you to try to check that answer in the same way we did with x and see if you can confirm that that is correct. Okay, so the first 3 problems, you will see something like this for sure on the quiz. You'll have to set up and solve proportions, or actually the proportion will be set up, my apologies, but you'll have to figure out how do we solve these proportions involving variables, expressions, numerators, denominators, all that good stuff. You're going to have to figure out how to solve these proportions. Moving on to question 2. So this asks you to explain why triangle BMN is similar to triangle BAC. The idea here is to get you thinking all about mid-segments, okay? So mid-segments is one of the topics we covered, and there's 2 really important things about mid-segments. Remembering that a mid-segment is defined as connecting the midpoints of 2 segments. We are given that it is the midpoints, so we can say BN is congruent to NC, BM to MA. And MN would be a mid-segment, meaning that MN is 1/2 of the length of AC. The other thing we know about mid-segments is that they are parallel to their respective base. So MN is parallel to AC. And the fact that they're parallel lets us know by corresponding angles in our properties of parallel lines and transversals that angle BNM is congruent to BCA, and also BMN is congruent to BAC. So this is also the case. And we can look and we can say that B is reflexive to itself. B is a part of the smaller triangle if I draw it here, and the bigger triangle if I draw it here. I have BMN and BAC. So B is reflexive to itself. We said that angle M was congruent to angle A, angle C to angle N. We said that BN would be like a single tick mark compared to BC would be double that. So we could call it 2x if this is x. And then if BM is 2 tick marks, and we call that y, this is 2y. And because MN is a mid-segment, if we call this z, then this is 2z. And so the idea is, the reason we know these triangles are similar is because they have all congruent corresponding angles and all proportional corresponding sides. Because all of our sides, we can say, are double. X, the side BN, is half the length of BC, BM is half the length of BA, and Z is half the length of 2Z, or sorry, MN is half the length of AC. So this is enough to tell us that these triangles must be similar because similarity is defined as having all equivalent congruent angles and all proportional sides. On the answer key is more of a proof approach to showing this exact information, but this is more of a just talking through why we know they're similar, and this is the information you would want to know and have down solidly for the test or for the quiz. You want to just know these properties of mid-segments, and you want to know that that means that all the sides are congruent. All the angles are congruent and all the sides are proportional. My apologies. So being able to understand everything I said there is definitely a must. Moving right along, let's see. All right, so now we have our areas and perimeters. So it says the perimeter of a trapezoid is 46. Its area is 108. So we have some trapezoid with perimeter 46, area 108. Find the perimeter of a similar trapezoid whose corresponding sides are 2.5 times as long. So we know that the perimeters scale directly with the side lengths. So if their sides are 2.5 times as long, the perimeter is going to just scale directly by that scale factor, and we would do 46 times 2.5. Okay, I'll put that in a calculator, though there's plenty of ways to do that without one. And we would say that the perimeter would be 115 of our similar trapezoid, because it scales directly. However, if we want the areas, remember that areas are two-dimensional, so we are scaling by 2.5 twice, or we are multiplying by that scale factor twice. So we take our initial area and we multiply it by 2.5 squared. It is the square of our one-dimensional scale factor if we are going into 2 dimensions with area. 2.5 squared is going to give us 6.25. So we take 108 times 6.25. And we check that and we get 675 square units. Okay, so that is if we are given perimeter and area, given a scale factor. We know that the perimeter scales directly with the scale factor. The area is the square of the scale factor is how we map there. Other way we could approach this problem too, so we can look at scale factors, we can also look at proportions. So I could say that the scale of 2.5 over 1 is equal to x over 46. 2.5 compared to 1 must match the ratio of x over 46, and then we would solve this proportion, and we would also get 115. Similarly, we could take 2.5 over 1, that is our regular scaling ratio or proportion, and square it, giving us 6.5 over 1, and we can set that equal to the ratio or proportion of the areas. So this is another way we can set this problem up and solve for the area. Cool. In the next example, it says herd and herdling are similar rectangles. The area of ling is twice the area of herd. So we have a scale of our areas. Find the value of x. And if we look at x is corresponding to 1. That is a ratio, or they are corresponding as side lengths, but we know the scale factor of the area. So if the scale factor of the area is, let's see, twice, so our area scale factor is times 2. We need to take the square root of that to figure out the scale factor of the sides, or the perimeter. And so for square rooting 2, we're just going to leave that as the square root of 2. It's approximately 1.4, but we're just going to leave it as square root 2 to stay nice and exact here. So the area scale is times 2. That means our square root 2 is the one-dimensional scale, or for the side lengths. So from x to 1, we're going to use that scale factor. It says area of ling is twice the area of herd, so we are going to divide by square root 2 if we want to go from x to 1, or if we want to go from 1 to x, we would multiply by square root 2, depending on which way we are scaling. 1 times square root of 2 is simply the square root of 2. So x equals square root of 2. We can also choose to solve this by using a proportion. So if I know that square root of 2 is my 1D scale factor, right, the perimeter is, or the side lengths are 1 over root 2 compared to 1 over x. And then we are able to solve this proportion where we know that x must equal root 2. key detail here is area is the square of the side length scale factor. We need to take the square root to go the other direction. Now it says find the perimeter of herd if the perimeter of Ling is 6. So perimeter is one-dimensional. If the perimeter of Ling is 6, and we know that the scale one-dimensionally is to go from Ling to herd, we would divide by the square root of 2. So this is equivalent to 6 over square root 2. And if we were to rationalize the denominator here, we can multiply by square root 2 over square root 2. We would get 6 root 2 over 4 equals 3 root 2 over 2. Don't worry too much about that. Don't recall having covered that in too much detail so far. And I don't believe on the quiz that you're going to have to do anything with simplifying radicals. Good little review if you have seen it, but don't worry too much. What we can also set up is a proportion similar to before. So we can say that the proportion of 1 to square root 2 is equivalent to the perimeter over 6. And then we could solve this proportion. So we could get 6 equals the perimeter times square root 2. And then we end up doing the same math when we divide out root 2. Okay. So that is that. Hopefully that's not too confusing. The square root 2, I think, adds like a degree of difficulty here that you will not necessarily see on the quiz. The key idea is that if you have the area scale factor, you take the square root of that to get to the side length scale factor. That is the key idea. So don't worry as much about the doing math with square roots of 2 or radicals. Just know that whatever the scale factor of the area is, you square root that to get the scale factor of the side length.